All right, so what we're going to be talking about today is something called completing the square. Okay, completing the square is actually pretty simple. It's like one of my favorite things to do. It's what we use when we can't factor. It's how we make something not factorable factorable. Okay, so go to the next page. You're going to see in just a moment. Okay, so we're going to solve equations by completing the square. So like I said, a lot of times we can't factor, so this is going to allow us to factor. And it has something to do with perfect square trinomials, which we're going to see in just a moment. Oh, hello. Ignore, ignore, ignore. Forgot to take it out. Okay, so we've got this nice quadratic, right? What's the first thing that pops in your head? Subtract the 36. Okay, so generally we would like to subtract the 36. In this case, we're not going to. Okay, so we're going to do it a little bit differently this time around. Okay, so what we're going to do is we're actually going to focus our attention on this side of the equation. I want you to ignore that 36 for a minute. What do you notice about the left-hand side of this equation? It's factorable. Yeah, how does it factor? Excellent. X plus 5, x plus 5. That's what we call a perfect square trinomial. Perfect square trinomial, because how can I rewrite the left-hand side now? How can I rewrite this left-hand side so that I only have to write x plus 5 once? X plus 5 quantity squared, good. X plus 5 quantity squared equals 36. Okay, so this is called a perfect square trinomial, when it's factorable so that each factor is the same. Okay? All right, so now we know how to solve things that are squared. How do I get rid of a squared? If I square it again, it'll be to the 4th. Square root. Take the square root of both sides. Good. Okay. So what's the square root of x plus 5 quantity squared? Good. What's the square root of 36? And? Positive and negative. So you have to have that plus and minus. Whoops. Okay, when you take the square root, you always have to have that plus and minus. This becomes incredibly important when we're completing the square. Okay. All right, so again, I'm solving for x. What do? Subtract the 5 over. Good. So I have negative 5 plus and minus 6. How many solutions do I have here? I have 2. How do I get them? 2 separate equations. What are they? Good. Excellent. So what are my answers? 1 and negative 11. Great. So negative 11 and 1 are my solutions. Okay, so what? So this is completing the square. Okay, so we factor it, we take the square root of both sides, and we isolate the x. So what do you think? Awful? No, it's not bad, right? We're going to do a lot more practice with this. I'll wait. Long pause. How you doing, Frank? Moving on. Let's look at the next one. Okay, so essentially what we wind up doing is if the equation isn't a perfect square trinomial to start with, that's factoring on the left-hand side where it came out nice and pretty and I could do the quantity squared, right? If it doesn't work like that on the left-hand side, what we do is we move over that c term. Do you guys know what I mean by c term? You're kind of looking at me like I'm crazy. Ax, oops, I forgot the x. Ax squared plus bx plus c equals 0, right? So we move over the old c term that we don't want. We create a new one and we put it in its place. Okay, so by doing that, it allows us to make it factor pretty, okay? So it's an equation. So if I put it on one side of the equation, where else do I have to put it? Yeah, because it has to balance out, right? So we find that new C term, we add it to both sides, and then we can factor it all nice and pretty, okay? So in order to do that, you have to know this right here. B over 2 quantity squared. Have to have it memorized. What is it? Everybody say it.
B over 2 quantity squared.
Okay, you have to have that memorized, that B over 2 quantity squared, okay? That's how you find your new C term. Got it? Okay, so let's look at one. We're going to start by why do I keep doing that? We're going to start by just finding the C term. Okay, we're only finding the C term for this one. So, what do I have to use? What formula? Say it again. B over 2 quantity squared. Good. B over 2 squared. Okay, what's B? Where do you even see a 4, dear? 8. What kind of 8? Negative 8. Over, and I'm going to do what to it? Good. What do I get? Negative 4 squared. Negative 4 squared, which is 16. Okay, so there's my new C term. Okay, so all I'm going to do is I'm going to take that C term, and I'm going to plug it in for where my old C was. Is it ever going to be minus a negative? Is it ever going to be a negative? No. Why is it never going to be a negative? Yeah, I'm squaring it, right? What happens when I square a negative? It becomes positive. So your C term is always going to be plus. It's always going to be positive. Okay? Okay, so you're ready to try a whole one? Okay. Okay, next page. Okay, so we're going to give this one a shot. You guys ready? All right, so is the left hand, are you ready? Are you ready? Is the left-hand side a perfect square trinomial? No. Okay, so my first step is to do what? I have to find a new C, but before I can find a new C, I have to remove the old one. Where am I going to put it? The other side. Very good. So my first step is to get rid of that C term just by subtracting it to the other side. Notice I left a big space. X squared minus 12x. Because what do I want to put in there? My new C term. Good. Okay, I want my new C term to go there. How do I find my new C term?
Quantity squared.
B over 2 squared. What's B?
12. Negative 12.
Negative 12 over 2 squared. Negative 6 squared, which is, okay. So there's my new C term. What am I going to do with it? Where? And? Good. What I do to one side of an equation, I have to do to the other. So I'm going to add 36 to both sides. We okay? Okay. I know. Are you ready? Okay, so left-hand side of the equation, is it a perfect square trinomial?
Yes.
Yeah, absolutely. How does x squared minus 12x plus 36 factor?
Plus minus 6. No, plus minus 6.
X minus 6, x minus 6. And that equals 31. Pretend like I didn't hear that, honey. Do I need to write it twice? How do I write it? X minus 6 quantity squared. Because if you say x minus 6 squared, what you're saying is this. Is that the same thing? No. Okay, so now what? Square root. If you square it, you're going to get x minus 6 quantity to the 4th power, right? So you got to be careful. What you do to one side, you must do to the other. We didn't square the left. We just wrote it as 1. Okay. One more step. 31's prime. One more step. One more step. Add 6. So how many solutions do I actually have there? 2. I have 6 plus the square root of 31, and I have 6 minus the square root of 31. And that's completing the square. All right. Okay, so let's try another one, guys. We're going to move faster with this one, okay? First step. Add the 4. Good. We're going to add the 4 to the other side, right? It's not right now, but we're going to make it into 1. Okay. Okay, good. We moved over the old c that we don't want. We need to find the new one. How? b over 2 squared. Very good. What's b? And what's my new c term? What do I do with that new c term? To what? Where? And? And? Good. Plus 4. Oh, I'm missing an x, aren't I? Okay. Now what? Good. Factor the left-hand side. How does it factor? Good. X plus 2, and we can skip that step and go to quantity squared. Okay, because that's the point of this. It's always going to this. Now, the key to this, the trick, is you always take the square root of your new c term. What's c? What's the square root of 4? 2. Okay, so no matter what's in that c term, you just take the square root and you put it here. Okay, signs are the same. They're both positive, so that's where you get this plus here. Okay, equals 8. Square root both sides, good. X plus 2 equals plus or minus the square root of 8. And yeah, we can break down the square root of 8. That's fine. It's 2 radical 2. Good, guys. Okay. I have one more step. Subtract the 2. Yeah. I heard somebody say minus the 2, but I was not listening because that's not how we speak. So I ignored you. Do you get it now? No. Okie dokie. So how many solutions do I actually have here? 2. I have negative 2 plus 2 radical 2 and negative 2 minus 2 radical 2. Okie dokie. Let's look at the next one. So what happens when we get complex solution? What's a complex number? Not even a little bit. What's a complex number? What does a complex? Good. It has an I in it. I stands for imaginary. How do we get imaginary numbers? We do. How? Negative underneath the radical. Awesome. Okay, so we get complex numbers when we have a negative underneath the radical. Okay, so if I were to take this and solve it graphically, what would happen? Why? What does it mean graphically, though? Where are the solutions found? We don't know that. I want everybody to graph that and find me the solutions graphically. Graph it and find the solutions graphically. I'm going to pause and give you a minute. Okay, so when we graphed it, we got something that looked like this, right? Where do I generally find solutions? Where are the solutions found, guys? No. It's when we cross the x-axis, right? All of our solutions are where the graph crosses the x-axis. What's the problem with this one? It doesn't cross the x-axis. That tells us that my solutions are imaginary. Okay, if it does not cross through the x-axis, the solutions are imaginary. Okay, so let's go ahead and solve this using completing the square. Okay, what's the problem to start with? How do I start this? Subtract over that 36. Go ahead. So I'm going to pause here. I'm going to let you guys solve this out, and we'll come back. Okay, first step, guys. Good. Subtract the 36. Now what? Good. Negative b over 2 quantity squared, which gives us 16. What do I do with the 16? Add it to both sides. Stop it. So how does this factor? Good. X minus 4 quantity squared. And this becomes negative 20. Okay. Take the square root. Good. So we get x minus 4 equals plus and minus the square root of a negative 20. How do I break down negative 20, square root of negative 20? Good. Square root of negative 4, square root of 5. What's the square root of negative 4? 2i. Remember, whenever you have a negative underneath the radical, you get I. So we have x minus 4 equals plus and minus 2 radical 5 I. Notice where the I is? At the end. Is it underneath the radical? No, absolutely not. Okay. One last step. Good. X equals 4 plus and minus 2 radical 5 I. 4 plus 2 radical 5 I. 4 minus 2 radical 5 I. Okay, so that's how we get complex solutions. Okay. No, we're not done. Okay, we ready? Okay. So this next one's very important, okay? Because they're not always going to have a nice, pretty 1 for a leading coefficient. What's the leading coefficient for this quadratic? 5. The leading coefficient is the coefficient that's in front of the x squared, okay? So leading coefficient is 5. Now, before we can complete the square like we normally do, we have to take one additional step, okay? My first step for this is to divide everything that's there by that leading coefficient. What's my leading coefficient again? Okay, so I'm going to divide everything up here by 5. Bye, guys. Okay, everything gets divided by 5. So that cancels. And we get this. Okay. Do I like the way it's set up? No, why not? What do we normally like to have on the same side? The x's, right? So I need to move something. What do I need to move? The 6/5 x. So we're going to move that over by subtracting it. And we're going to leave that 8/5 on the other side because what we're going to want to do is find our missing c term. Okay? So this is just completing the square. The only thing I've done different is that I've divided everything by the leading coefficient to make the leading coefficient 1. Okay, everything else gets set up in the same way. How do we find the new c term? b over 2 squared. So negative 6/5 divided by 2 squared. How are we going to find that value? Yeah, I'm not reteaching you fractions, guys. So you can take your calculator. And I see that I already have it in here. Okay. Notice where the large fraction bar is. I'm going to re-input it so you guys know what it looks like. I'm going to put in a fraction bar. And then in the numerator, I have a second fraction, don't I? So that's going to be your 6/5 over 2 squared. Enter. 9/25. Okay. So I'm going to add 9/25 to both sides. Are we okay? Now this is easy to factor. Why? What's the rule? What do I always do? Square root of the c term, right? Square root of the c term. What's the square root of 9/25? 3/5. Good. And then 8/5 plus 9/25. I can real quick just pop that in. 49/25. Okay. Good. Take the square root of both sides. So I get x minus 3/5 equals, what's the square root of 49/25? 7/5. Good. Okay. Always. Whenever you take the square root of something, it's always plus or minus. Yes. Okay, one more. Add the 3/5. Which is really 3/5 plus 7/5 and 3/5 minus 7/5. All right, we want to write them as fractions. 3/5 plus 7/5 is 10/5, which is 2. 3/5 minus 7/5 is negative 4/5. It's negative 4/5 and 2. Okay, so that's when you have a leading coefficient other than 1. You have to divide everything through by that leading coefficient and then work your way through it. Okay. Homework tonight is pages 26 and 27. Make sure you do it. We did not get as far as first period because we're too chitty-chatty in this class. So we got to learn to move a little faster. 26 and 27 is your homework in your packet for tonight. Okay. Tomorrow we will finish this lesson. We're going to talk about changing from general form to vertex form using completing the square. And we're going to talk about factor by grouping. Okay.